Let us now do few examples based on the theorems we have learned. So let us recall the decimal expansion of rational numbers. If x is a rational number which is of the form p by q, where the prime factorization of q is of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers, then the rational number x has a terminating decimal expansion. If not, if q is not of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers, then the decimal expansion of x is non-terminating recurring. We know that the decimal expansion of a rational number will be either terminating or non-terminating recurring. So, if x is a rational number and the prime factorization of the denominator of x when it is written in its p by q form is in the form 2 raised to n into 5 raised to m, then the decimal expansion of x will be terminating. If not, if q cannot be written in the form 2 raised to n into 5 raised to m, where n and m are non-negative integers, then the decimal expansion of x is non-terminating recurring. If few rational numbers are given and we are asked to tell whether the decimal expansion of these rational numbers are terminating or non-terminating recurring without doing the actual division, what you have to do is you have to write the rational number given in its p by q form where p and q are co-primes. So let us see 13 and 3125. We know that 13 and 3125 have no common factors. Therefore, these two numbers are co-primes. So next thing you have to do is you have to prime factorize the denominator. The denominator in this rational number is 3125. I have prime factorized 3125. And when I prime factorize 3125, I got 5 raised to 5. So I can write 5 raised to 5 as 5 raised to 5 into 2 raised to 0 because 2 raised to 0 is 1. So instead of writing 1, I can write 2 raised to 0 because I want to check whether this is of the form 2 raised to n into 5 raised to m. In order to make it in that form, I have written the prime factorization of the number 3125 in the form 5 raised to 5 into 2 raised to 0. Here n is equal to 0 and m is equal to 5. N and m are non-negative integers. Comparing this prime factorization with this, I can infer that x has a terminating decimal expansion. Since q when prime factorized, I got it in the form 2 raised to n into 5 raised to m. The decimal expansion of this number will be terminating. So, in the question it is asked, if the number has a terminating decimal expansion, you have to find the decimal expansion without doing actual division. You have to find the decimal expansion of this number without doing actual division. So, what you have to do is, you have to make the powers of 5 and 2 same. So here when you observe, here 5 has power 5. So in order to make the power of both 5 and 2 same, I have to multiply both the numerator and denominator with 2 raised to 5. Multiplying the numerator and denominator with the same number does not change the value of the rational number. So when I multiply 2 raised to 5 and divided by 2 raised to 5, there is no change to this rational number. After making the powers of n and m same, here n is 0 and m is 5. So I multiplied with 2 raised to 5 to make n and m same. After making the value of n and m same, you have to apply the formula a raised to m into b raised to m equals ab the whole raised to m. Since the powers are same, I can write this as 5 into 2 the whole raised to 5. 2 raised to 5 is 32 and 5 raised to 5 into 2 raised to 5 is written as 5 into 2 the whole raised to 5. Now simplifying, when you have to do multiplication and you get 13 into 32 is 416 and 5 into 2 the whole raised to 5 is 10 raised to 5. You can easily write the decimal form of this number by moving decimal places. So 416 divided by 10 raised to 5 will be having 5 decimal places. So you have written this number in its decimal form without doing actual division. Now let us see the next question. 15 divided by 1600. When you are given a rational number and you are asked to check whether the decimal expansion of that number is terminating or non-terminating recurring, you have to first write the given rational number in its simplest form. When you observe 15 divided by 1600, 15 and 1600 has common factor which is 5. So I have to first cancel the common factors and I get 3 divided by 2 raised to 6 into 5 raised to 1. What I have actually done is I have prime factorized both the numerator and denominator and I have cancelled out the common factors. After prime factorizing, I got 1600 as 2 raised to 6 into 5 raised to 2. And the prime factorization of 15 is 5 into 3. After cancelling out the common factors, I got 15 divided by 1600 is equal to 3 divided by 2 raised to 6 into 5 raised to 1. So here P and Q are co-primes and the prime factorization of Q. Q is 2 raised to 6 into 5 raised to 1. The prime factorization of Q is of the form 2 raised to n into 5 raised to m. Therefore, this number x this rational number has a terminating decimal expansion. So we are asked to find the decimal expansion if it has a terminating decimal expansion and without doing actual division. So what you have to do is you have to make the powers of 2 and 5 same. So I have to multiply this denominator with 5 raised to 5 to make the powers of both 2 and 5 same. So the first step in finding the decimal expansion without doing actual division is making the powers of 2 and 5 in the denominator same. So here I have multiplied the numerator and denominator with 5 raised to 5. I have applied the exponential law a raised to m into a raised to n equals a raised to m plus n. So 5 raised to 1 into 5 raised to 5 equals 5 raised to 1 plus 5. So 1 plus 5 is 6. So we get 2 raised to 6 into 5 raised to 6. 3 into 5 raised to 5 equals 9375. And then you have to apply the law a raised to m into b raised to m equals ab the whole raised to m. So that I get 2 into 5 the whole raised to m which is 10 raised to 6. Now we can easily write the decimal expansion of this number by moving decimal places and I get 0.009375. Next question is 129 divided by 2 square into 5 raised to 7 into 7 raised to 5. First thing you have to do is you have to check whether the number is in its P by Q form as we mentioned here. P by Q form where P and Q are co-primes. So when you observe this number, we know that 129 and 2 raised to 2 into 5 raised to 7 into 7 raised to 5 has no common factors, which means that these two numbers are co-primes. And now you have to observe whether the denominator q is of the form 2 raised to n into 5 raised to m. This denominator is not of the form 2 raised to n into 5 raised to m because we have a 7 raised to 5 also along with these two numbers in the denominator. So that the decimal expansion of this number is non-terminating recurring. Since we cannot write the denominator in its prime factorized form as 2 raised to n into 5 raised to m. Next question is 77 divided by 210. So first you have to write this rational number in its simplest form. Simplest form we get by cancelling out the common factors. So we have to write both the numerator and denominator in its prime factorized form and cancel out the common factors. After cancelling out the common factors, I get 11 divided by 2 into 3 into 5. So when you observe the denominator here also, we can see that the denominator is not of the form 2 raised to n into 5 raised to m, since we have a 3 in the denominator. Therefore, the decimal expansion of this number is non-terminating, repeating. And the last question in this section is 6 divided by 15. So first thing I have to do is I have to write the numerator and denominator in its simplest form after cancelling out the common factors. 6 equals 2 into 3 and 15 equals 3 into 5. After cancelling out the common factor, which is 3, I get 2 by 5. The denominator in this case is of the form 2 raised to n into 5 raised to m. In order to make the powers of 2 and 5 same, what I have to do is I have to multiply with 2 raised to 1 in the numerator and denominator. After multiplying the numerator and denominator with 2 raised to 1, I get 4 divided by 10, which is equal to 0.4.